To continue the conversation, I wanted to delve into cryopreservation. It's no question that cryopreservation is critical for cell therapies across the board, but in the context of stem cells and stem cell derived therapies, Catherine, we'll start with you. How does the need for cryopreservation differ by product type?
Yeah, so I think as we've been talking about autologous versus allogeneic therapies, it highlights that cryopreservation is essential for allogeneic therapies. If we're going to make an off-the-shelf product, we need to be able to store it on the shelf. And so that's a huge focus at BitBio. I think another aspect is whatever we're using to store the material, and ideally would be also able to be delivered to the patient directly. So if you could minimize any kind of manipulation needed at the clinical site, that would be another advantage. And then obviously the main goal of cryo is to preserve the cells intact without losing viability, without losing integrity of the cells.
Great, thank you. And I'll pose this to all three of you. We had a registered question before. What are the biggest challenges with just cryopreservation currently? Catherine, maybe we can continue with you if you wouldn't mind.
Sure. I think one aspect we've been looking at is making sure that if you have a promising excipient in your cryopreservation media, to make sure that it is GMP sourced, that it's generally recognized as safe. And, you need to balance, again, that physiological nature of the cryopreservation media to make sure that, you could also deliver it to the patient. So we have a variety of products as well. So we have a lot of neuron types, in addition to hepatocytes and microglia. And so each different cell type can be a little bit different in terms of when you need to cryopreserve them in the growth process and what condition you need them to be in when you thaw. And then speaking of thawing is a huge part of cryopreservation that I think sometimes is forgotten. So not only do you need to look at how you cryopreserve the cells, but you also need to make sure that you're thawing them in a consistent manner and in a way that preserves the viability of the culture.
You want me to add a little to that?
Yeah, please.
I totally agree with what you last. I have to remember all the things I was going to say, but what you just last said is really important, right? The ability to handle the thawing and the material, and that's one of the reasons why we're trying to make products that, I don't want to say it's foolproof because nothing is foolproof, but right, literally thaw at the bedside and infuse, so there's no manipulation for the clinical site. I think is important as well, but. I think, we started to talk about this with cryopreservation, and Catherine said it as well. Not all cell types are the same when it comes to cryopreservation, and some cell types really don't like to be cryopreserved. In my world, we're doing all, again, hematopoietic and immune effector cells. Stem cells are they're pretty good, right? But we know every time you cryopreserve something and thought you will have cell loss, right? It's how do you minimize some of your cell loss unless you have an absolutely 100% uniform cell population. How do you determine what cells are not surviving that freeze thaw? Are they the important ones? Are they ancillary ones? How, and for us, that's really important because we start from cryopreserved material, isolate stem cells. We start with a purified stem cell population, but it's post cryopreservation. And then we make our products and cryopreserve at the end, right? So we have 2 cryopreservation steps for our therapies. And again, the stem cells all do really, that's not usually the issue, but NK cells have been a hard population of cells to cryopreserve and maintain viability, cell recovery, right? So are you getting back more than 50% of what you froze, right? And you need to know this for cell dosing for your clinical trials. So, viability, recovery, and then most importantly, potency, right? You have to demonstrate that that your cells are as potent as when you put them in whatever vessel as when you thaw them and infuse them. So I think these can be very tricky. Developing these assays for thawed material can be pretty tricky. And thankfully, we've been able to do this for our NK cells and our monocytes and macrophages and have good recovery and good potency. We've demonstrated that. And in fact, sometimes the cryopreservation gets rid of some of the cells we don't want to interfere with how our cells are functioning. So I think these are all really important considerations, but I do think the clinical site that is going to be handling the cells, that has to be considered too.